bit more technical than the other ones, but is as well is very, very oriented to multidisciplinarity as well. The problem that we are going to discuss is how to apply data fusion to some practical systems, and in particular to cybersecurity. That is one of the applications that deserve more attention in the present situation all over the world. So first of all, I will spend some time to describe what is data fusion, also for people who are not so much accustomed with this concept. Which is data fusion? Is not only, as one can think about, a problem of putting together data. Is not so simple. The process of data fusion is a structured process that is usually implemented in different layers, in different steps, which serves to transform raw data. What is raw data? Generally, data which are not significant per se. So, heterogeneous data which are not significant if considered singularly. This process implements the task to put together this data, but in a very structured and useful form. This is the basic concept of data fusion. So when talking about data fusion, there are many ways to treat this concept. For example, many people think about sensor management or resource management or sensor fusion, things like that. Correlation, tracking, information fusion, and so on. So in order to provide some guideline, the joint directors of laboratories workshop, which happened many years ago in 1980, made some very important progress in this field, and they defined a structured system for data fusion in order to describe the data fusion as a multi-level process, which is partly machine-oriented and partly human-oriented. And this process is described by this picture here. So basically, we have many levels. We start from level 0, which is the basic level. I will describe very briefly which is that in particular. Source preprocessing. Then we go to object refinement, level 1. Then we go up to these levels, level 2, level 3, level 4, which are situation assessment, threat assessment, process refinement. Which is the basic concept of this structure? Is basically to give a guideline for everyone working in the data fusion environment in order to understand which are the most important levels that data fusion has to go through in order to be useful for the whole system. In particular, in this talk, we will examine which are the pros of applying the so-called global data fusion. Which is global data fusion? Is the application of all these levels of the system to data fusion, not stopping only at the first level, as usually is done in a lot of systems for many reasons, maybe economical reason or strategic reason or other problems. This is the description, very synthetic description of the 5 levels. Source preprocessing, it's a fusion of data at signal level, normally. Object refined is association of different data belonging to the same environment. And the top 3 levels are more sophisticated levels: pattern recognition, risk evaluation, prediction, resource management. We will describe better just now in our discussion. Some history about data fusion, even if this history is not complete, of course. For example, the concept of global data fusion has already been applied to system dedicated to the urban environment control, for example. This is a network of sensors, for example, cameras or other type of sensors that control a city. In this case, most systems have been designed taking into account this concept, the global data fusion. Other systems have to be designed with the same concept. Another field of application is the multistatic target recognition and detection. This is, for example, air control systems. When we have different sensors in an area, this is an area in the north of Italy, we have the need to put together the data coming from these different sensors, so we have the need to apply the global data fusion concept. One field that is interesting for the application of this concept is the cybersecurity, and in particular, I will talk about cybersecurity of critical infrastructures. This is one, I say, of the third millennium challenges, because the cybersecurity of these sites, such as, for example, border control, electricity, the electricity grid, and territory protection, transport, and so on, is a vital backbone of every nation. So it's quite important to make these sites secure, particularly in the sense of cybersecurity. But also, of course, in the sense of physical security. One system that has been designed to make this work, to control the security of the critical infrastructure, is this one. As you can see, we have here a fusion of sensors, human in the loop, intelligence data, which are human data, history data, this is big data, environment data, and so on. And this is the core processing of the system. The triangle here means that as we are dealing with big data, we are reducing this data, and we are going from no real-time processing to real-time processing. This is the so-called map-reduce algorithm that has been used for the first time by Google. Okay, some description about this system. Of course, we have heterogeneous data. We have intelligent external sources. We have a system which is also part of the internet, because all the structures inside the system communicates partly by internet. So it's quite important that the system goes outside a limited domain. So in this case, global data fusion is of fundamental importance. Now, I will try to convince that the application of the concept of global data fusion is important to achieve the main requirements of the system, that is the security of the system for this kind of applications. So I will start from data fusion level 0 and 1, which are the lowest level. In this case, cybersecurity takes into account only of the entities inside the system. For example, which are the computers, the network, the data flow, the operating system, hardware, and so on. These are certainly important parameters, but they are only the basis for going up with the extension of data fusion at higher levels. Many systems actually stops at this level, and this is probably the reason why there are still gaps in the efficiency of cybersecurity system nowadays. So what is level 2? Level 2. Level 2 is situation assessment, as we saw at the beginning. Situation assessment means that the multiple features of the network are not only taken into consideration, but are also processed in order to find pattern matching and machine learning results from this. And in this level, we apply this kind of algorithm, decision theory and Dempsey-Schaeffer evidential reasoning. The result is that we have a real estimation of the more likely attacks in our system. Just to explain better this concept, I will show some result that we have. This is quite a summary of what happens in practical systems. How works this level? When we introduce in the environment characteristics the network awareness, the threat awareness, and mission awareness, we obtain a system awareness that goes from zero when we have no knowledge of these basic parameters to 1 when we have a deep knowledge of these parameters. So we can see that the improvement is quite important. Let us go a bit higher at level 3. Level 3 is the impact assessment. With impact assessment, we want not only to understand which are the elements which can cause some vulnerabilities in our system, but also to understand their strategy. This level works with this kind of algorithms. Expert systems, blackboard architecture, fuzzy logic. Because in this level, we have to estimate the possible strategies of the threat. And this cannot be done by using deterministic algorithms. In fact, these are, especially fuzzy logic, is kind of which reason in a in non-deterministic way and deal with imprecise data and problems. So very often we get many solutions rather than one. As a result, we have an estimation about the probability of recovery of the system in case of attack. I can show what happens as a summary of the experiment that we made by applying this level. What happens? By knowing the threat capability and as much as we know our network defense capabilities, we go on with increasing the probability of recovery. In fact, when threat capability are very low and our network defense capabilities grows up, we can reach 1, which is complete probability 1, that is theoretical probability 1 of recovery of our system. Then, to go higher in our structure of the global data fusion, there is process refinement. This, just to understand better from the beginning, this concept is a backward process. Process refinement is some backward process which refines our defense strategies by applying the knowledge of history, the history of attacks. And this requires a certain participation of the human agent, which happens by means of menus, dialogues, and natural language interaction. Also for this, for the application of this process, we have some results that are shown in this slide. So, depending on the threat options, of course, as much as we have threat options available, we lower our probability of blocking threats, but increasing monitoring tools, we can increase the same probability. Okay, so let's try to give some practical results of this discussion. So the performance evaluation. So we said, first of all, the system awareness grows as much we know the environment parameters under control. This means to know both the threat capabilities and our defense capabilities. The probability of recovery improves when we can control threat capability and defense capabilities. Of course, we can have a fast recovery when we leave the attacker with less options available. The probability of blocking threats improves when using as much as possible monitoring tools. As much as we can monitor the system, as much as we can achieve security, higher security level. And as a final parameter, the network security is a function of data fusion capabilities of the network and the capability of threats that can attack potentially the system. So the network security in general increases with the high quality of data fusion. And we have also another diagram which describes the situation. And the situation is this. If we have very small data fusion capabilities, so this means we apply data fusion only at the lowest levels, we can have a network security which is poor. So we stay in this area here. As much as we improve the data fusion capability, applying the concept of global data fusion, we are going in this part of the diagram. So we can achieve as much as possible the maximum level of network security. In this case, we describe the 0 level as the minimum and the 1 level as the maximum. Good. So, conclusions. We have these 4 points which are important for the global data fusion concept. The situation assessment is the first concept we described at the beginning, is strongly dependent from an accurate knowledge of the environment characteristics. So both system health parameters and external threat parameters. Impact assessment, this is the level 2 of the JDL structure, corresponds to the data fusion capability which coordinates the defensive action of the network. How can we enhance this parameter? By having a suitable number of defense measures versus threat capabilities. So as much as we have strong threat capabilities, as much as we have to increase our defense. Process refinement, I say again, is a backward process, which is to tailor the defense capabilities with respect to the threat dimension. So is some loop back in order to better structure our defense resources. And this is level 4. As a final parameter, we estimate a network security, which is our goal, our final goal, to understand how much our network is secure from an external attack. We can see that this security is consistently increased by applying more data fusion capabilities and by incrementing the capability of threat detection through a suitable combined process based on the global data fusion concept. And I hope to recover some minutes from the previous speakers. So,
yeah, you did. Thank you very much.